Welcome to Electron. Now we're going to try to solve this circuit which has inductors in it. What we mean by solving is we're trying to find the current through the first inductor and the two inductors in parallel here. We're trying to find the voltage across each of the inductors as well as the voltage across the entire circuit. We're given that the current entering the circuit going through the first inductor is equal to 8 minus 4 e to the minus 10t in milliamps, and we're also given that the initial condition that the current through the inductor here, the second inductor in the branch, is equal to minus 1 milliamp at t equals 0. So where should we start? Well, since we're given the initial condition of I2, I believe we can find I1 and I as well when the time equals 0. So let's start with that. So the current when time is equal to 0 is equal to, what we're going to do is just take this equation right here and plug in 0 for t. That gives us 8 minus 4 e to the minus 10 times 0. So the exponent here is 0. E to the 0 is 1. And this, of course, in milliamps. That gives us 8 minus 4 milliamps, which is equal to 4 milliamps. That means the current entering the circuit at t equals 0 equals 4 milliamps. We're also given that the current through the second branch is equal to negative 1 milliamps. And from that, we should be able to find the current in the first branch right here. We know that I equals I1 plus I2, which means that I1 is equal to the total current minus I2. And of course, that holds then for the initial condition that I1 when t is equal to 0 is equal to I when t is equal to 0 minus I2 when t is equal to 0. Now let's find out what those are equal to. The current when t equals 0 right here is equal to 4 milliamps minus the current through I2 when t equals 0, which is a minus 1 milliamp, which means that we have an initial current of 5 milliamps through the first of the two branches in the parallel branch. So now we know the initial current in all three inductors. Secondly, let's see here, we need to find the total voltage V1 and V2. How do we figure that out? Well, let's start out with finding the voltage across this one right here. We can say that the voltage V3 is equal to inductance 3 L3 times di dt. Now we don't know yet what di dt is, but we do know what I is, which means we can find di dt by taking the derivative of that. So let's do that here. Di dt is equal to, well, the derivative of a constant is 0, and the derivative of this gives us minus 4 e to the minus 10t times the derivative of the exponent, which is minus 10, which gives us 40 e to the minus 10t. That's the derivative with respect to time of the current going into the circuit, which means we can then find the voltage across that inductor right here, which is equal to 2 henries times di dt, and that's times 40 e to the minus 10t. Now the units of that would be the derivative of the current, di dt, that would be the derivative of amps. In essence, when we multiply this, we get 80 e to the minus 10t. And what are the units? Well, we have inductance in henries, current in milliamps, that this would be millivolts. What about the voltage for V1 and V2? To do that, what I think I need to do is find the total voltage, because I realize here that, of course, V1 equals to V2 because they're two branches of a parallel branch. And I know that V total minus V through 3 to inductor 3 must equal V1, which is equal to V2. So my approach here is to find the total voltage, subtract V3 from it to get V1 and V2. How do we get the total voltage? Well, for that we need to first find the equivalent inductance. the equivalent inductance. So what we need to find here is we need to find L total or L equivalent. Let me draw some lines in here so we don't get too confused with all the equations on the board, because after all, there's a lot to be written here and there's only so much board space. So now I'm going to find the equivalent inductance, which means that I have to first add these two together, which are in parallel, and then add that to this one, which means they're in series here. That means L equivalent is equal to 2 henries plus the product over the sum of these two. That would be 4 times 12 divided by 4 plus 12, which is equal to 2 plus 48 over 16, which is 2 plus 3, which is 5 henries. 5 henries is the equivalent inductance of the whole circuit. So now I have the equivalent inductance, plus I have the, let's see here, do I have the total voltage? No, but I can find the total voltage here because I know di dt for the whole circuit. So V total is equal to the equivalent inductance times di dt, which is 5 henries multiplied times the di dt is 40 e to the minus 10t, which means that this would be equal to 200 e to the minus 10t, and that would be in millivolts. Next, what we need to do, since we know V3 and we know V total, we can then find V1 and V2 because we simply have to subtract one from the other, which means using this in combination, we can say that V1 is equal to V2, which is equal to V total minus V3. V total is 200 e to the minus 10t in millivolts. Subtract from that the 80 e to the minus 10t in millivolts, which is equal to 120 e to the minus 10t in millivolts. And that therefore is the voltage across either this inductor and that inductor. And finally, now we can go ahead and find the current through each of these two. We can find I1 and I2. So we found all of this already. Now we still want to find these two. At least I can show you how to find one of them. To find the other one, it's exactly the same. You can say that I1 is equal to 1 over L times the integral of V dt. And of course, that would be L1 and V1 dt, because it's in that particular branch. This is equal to 1 over L1, which is 4 henries, times the integral of V1 dt. Now, V1 dt is, where did it go? Oh, right here. So that's this one right here. So that's the integral of 120 e to the minus 10 t dt. Of course, to integrate that, you need to have a minus 10 dt here because we have a minus 10t in the numerator, which means we need to take a minus 10 out of here, and then the minus 12 remaining goes over here. So this can be written as minus 12 over 4 times the integral of e to the minus 10t times a minus 10 dt. So that gives us a differential in order, so we can integrate that. So now we're ready to integrate this. When we integrate it, we get the following. We get minus 3 times the integral of that, which is times e to the minus 10t evaluated from 0 to t. But then, of course, we still have to add to that, because we're calculating the current through branch 1. We have to add to that the current it had at t equals 0. So we have to add that to this integral, and the current when time is equal to 0 for I1, where to go? Right here. That was equal to 5 milliamps. So we have to add the initial current as well. So plus 5, and this is all in milliamps. So we go ahead and multiply all this times milliamps. First, we need to plug in the limits. That gives us the following. This is equal to minus 3. And the minus 3 does not multiply times the plus 5. So I got to be careful here. Put double parentheses around it because the minus 3 is only multiplied times the integral. The plus 5 is the initial current that I have when time equals 0. So this becomes minus 3 times, when I plug in the upper limit, I get e to the minus 10t. When I plug in the lower limit, I get e to the 0. E to the 0 is 1, so minus 1, and then plus 5. This is all in milliamps. When I multiply this together, that gives me 3 plus 5, because when I multiply negative 3 times the negative 1, I get a plus 3, plus 5, and then minus 3 e to the minus 10t. So finally I can say that this is equal to 8 minus 3 e to the minus 10t in milliamps. And that would be the current as a function of time through branch 1. Now, do I have the total current here somewhere? Total current is right here. There's my total current. There's the current through branch 1. So what do I have to do to get the current through branch 2? I simply have to subtract the current through branch 1 from the total current to get the current in branch 2. I don't have a lot of room left, but let me try it over here. So I2 is equal to I total minus I1, which is equal to this quantity right here, which is 8 minus 4e to the minus 10t. And I subtract from that this quantity right here, which is 8 minus 3e to the minus 10t. I know that I'm running out of room here, but I simply subtract this quantity from the total current. And so this gives me 8 minus 8, which is 0. Minus 4 minus a minus 3 gives me minus 1 times e to the minus 10t, which is I sub 2. And of course, that would be in milliamps as well. So there's the current in I2. There's the current in I1. There's the total current. And we have voltage 1 equals voltage 2, which is equal to that. And voltage total is here. And voltage 3 is over there. So now we have all the various parameters of this particular circuit. It's a little messy, but at least you can see that systematically, by using the equations, if you're given the current, you can find the di dt. You can use the di dt in this equation to find the voltages across different parts of the circuit. And that's how we do that.